Expanding pairs of brackets. Here are some examples. You would have seen these at GCSE. X plus 4 times x plus 7. My personal favourite way of doing these would be to draw out a table, have x plus 4 along the top of the table, x plus 7, the other bracket down the side of the table, and then multiply each term by each other term. So x times x, x squared, x times 4, 4x, 7 times x is 7x, and 7 times 4 is 28. So we end up with x squared plus 4x plus 7x plus 28. Collect together the like terms. In this case, these are the x's. X squared plus 11x plus 28. That's the expansion of that pair of brackets. The second example there, x plus 3 times x minus 8. Same method works fine. X plus 3 along the top, x minus 8 down the side. Multiply out x times x, x squared, x times 3, 3x, minus 8 times x, minus 8x, minus 8 times 3, minus 24. Just be careful with minus signs. X squared plus 3x minus 8x minus 24. Again, collect up the like terms. That would be the x's. 3x minus 8x, x squared minus 5x minus 24. If you look a bit deeper at this, here's another example. X plus 2 times x plus 1. When you times it out, you get x squared plus 3x plus 2. You get the middle number by adding the two numbers in the brackets. So 2 plus 1, that makes 3. That's the middle number. And you get the last number by multiplying the two numbers in the brackets. So 2 times 1 is 2. Here's another example. X minus 5 times x plus 3. When you times it out, you get x squared minus 2x minus 15. And again, you get the middle number by adding the two numbers in the brackets. And you get the last number by multiplying the two numbers. Minus 5 plus 3 is minus 2. And minus 5 times positive 3 is minus 15. Knowing this is useful, because if we now got x squared minus 7x plus 12 and we want to factorise it, we want to put it into brackets, we can use the fact we have just learnt. We need numbers that multiply to give the number at the end, plus 12. So that's either 3 and a 4, or minus 3 and minus 4, or 12 and 1, or minus 12 and minus 1, or 6 and 2, or minus 6 and minus 2. Those are all the different pairs of numbers that multiply to give plus 12. But which of those pairs adds to give the minus 7 in the middle? Minus 3 and minus 4. So the brackets originally were x minus 3, x minus 4. That's factorising. X squared plus 10x plus 16. Same idea. Numbers that multiply to give plus 16. 1 and 16, minus 1 and minus 16. 2 and 8, minus 2 and minus 8. 4 and 4, minus 4 and minus 4. Which of those pairs adds to give the number in the middle? Plus 10. Well, plus 2 and plus 8. So the brackets originally were x plus 2, x plus 8. X squared minus x minus 20. Numbers that multiply to give minus 20. We always have to be a little more careful when dealing with minus signs. So it's plus 1 and minus 20, or minus 1 and plus 20. 2 and minus 10, or minus 2 and 10. 4 and minus 5, or minus 4 and 5? Which of those pairs adds to give minus 1? Remember, it's minus, although it says minus x in the middle, it really means minus 1x. There's a missing coefficient we don't bother to write because there is no need. Well, plus 4 and minus 5 add to give minus 1. So the brackets originally were x plus 4, x minus 5. A quadratic equation has the form ax squared plus bx plus c, where a, b and c all have to be constants and a cannot be equal to 0. We can also factorise these equations. So here's some examples. X squared plus 6x plus 8. If we want to factorise it, the two numbers in the brackets must be, the number must multiply to give c, so they must times to give 8, and they must add to give b. So two numbers that times to be 8 and add to be 6. 2 and 4. Remember, however, that an equation with an x squared in it does not necessarily go into two brackets. You use two brackets when there are no common factors. X squared minus 4x minus 5, two numbers that times 3 minus 5 and add 3 minus 4. We could do the working out. In fact, let's do the working out. So we want two numbers that times to be minus 5. So our choices are minus 5 and 1 or 5 and minus 1. What other numbers time? Oh, that's it. So it has to be one of these ones. There's no other pair numbers that times be minus 5. Which of these add to be minus 4? Well, it must be that one there. Suitably drawn circle around it. So that means that when we factorise it, we get x minus 5, x plus 1. X squared minus 25. In this case, life is slightly different because we don't have a b term. So we're looking for two numbers that times 3 minus 25 and add to be, well, nothing. Well, if we think of numbers that times 3 minus 25, then we're looking at either minus 1 and 25 or 1 and minus 25 or minus 5 and 5, or that's pretty much it for numbers that times to be minus 25. Well, which of those adds to be nothing? It's only that one there, the minus 5 and the 5. So x plus 5, x minus 5 is the factorisation. This has a special name. This is known as the difference of two squares. It's very useful to recognise the x squared minus something squared and instantly see that it's the difference of two squares. It's one you should be on the lookout for. X squared minus y squared is x plus y times x minus y. Know it. Learn it. 4x squared minus 9y squared. Because once you know and learn that, you can recognise things like this quite quickly as the difference of two squares. It's 2x squared minus 3y squared. So 2x plus 3y times 2x minus 3y. Recognising the difference of two squares is useful in much of the maths we will be doing in the near future. 5x squared minus 45 sometimes you need to remove a common factor first. If we look at this, we've got 5x squared and minus 45. There's a common factor in both of a 5. If we take the 5 outside a bracket, we're left with 5 times x squared minus 9. X squared minus 9, however, we can now recognise as being the difference of two squares. So it's 5 x plus 3 x minus 3. Look for common factors. Factorise. Be on the lookout for things that make maths easier, like the difference of two squares. Sometimes we don't just have x's in brackets, we have 2x's or some multiple of x. So in this example here, we got x plus 3 times x plus 4. We use our table method we've seen before, and we can quite quickly work out that it's x squared plus 7x plus 12. In the second example down here, we have 2x plus 3 times x plus 4. So 2x plus 3 times x plus 4. So we end up with 2x squared plus 3x plus 8x, 4 times 2 is 8, plus 12. So in this case we end up with 2x squared plus 11x plus 12. When an x squared has a 2 coefficient, the rules are different. Two of the terms are doubled. In this case, it's those terms there that have been doubled. So the numbers in the brackets add to give the x term when 1 has been doubled first. So let's look at this factorisation here. We want numbers at times to give minus 3. So it's minus 3 and 1, or 3 and minus 1. However, it's a 2x squared, so one of the terms has to be doubled when we add them together. So it's either minus 6 plus 1 or minus 3 plus 2. The minus 6 comes when doubling the minus 3 term, and the 2 comes when doubling the 1 term. Or it's minus 6 plus 6 minus 1, or plus 3 minus 2, again doubling one of the terms. And it's which of those makes minus 5. Right, the minus 6 plus 1 is the one that makes minus 5. So the brackets originally were 2x plus 1 and x minus 3, because the minus 3 term had to be doubled, so that's the one that has to be being times by the 2. The minus 3 is doubled, so it must be the opposite side to the 2x. 2x squared plus 13x plus 11. So numbers that multiply to make 11. There's not a vast number of these. It's either 11 plus 1 or minus 11 and minus 1. Again, it's 2x squared, so one of the terms must be doubled. So it's either plus 22 plus 1 or plus 11 plus 2, or minus 22 minus 1 or minus 11 minus 2, doubling one of the terms. Which ones of those makes 13? The plus 11 and the plus 2. So the brackets are something plus 11, something plus 2. Whichever one is the one you want doubled is the one you want in the opposite bracket to the 2x. So it'll be 2x plus 11, x plus 1, because it's the one you want doubled by the 2. The 1 is doubled, so it must be opposite the 2x. 3x squared minus 11x minus 4. Hopefully you can guess what's going to happen. Numbers that multiply to be minus 4 are either plus 2 and minus 2, minus 4 or plus 1, or plus 4 and minus 1. This time there's a 3x squared, so what does that suggest? That suggests that one of the numbers will be tripled when the brackets are expanded. So it's either plus a 6 and minus 2, or plus 2 and minus 6, minus 12 and 1, or minus 4 and plus 3, 12 and minus 1, or 4 and minus 3. And which ones of those makes minus 11? The minus 12 plus 1. So it's the minus 4 is the one we want to have tripled. So the minus 4 must be in the other bracket than the 3x. So it'll be 3x plus 1x minus 4. The minus 4 triples, so it must be in the opposite side to the 3x. That's how we can factorise expressions that have something other than x squared at the start. Any number at the start.